Okay, everybody, I'm going to go through operations with sets and Venn diagrams with this video. Okay, so today in class, we did talk about the union of our sets, and hopefully you guys followed along that if I were to tell you that set A had the numbers 10, 20, and 30 in it, and set B had 5, 10, and 15, then the union of A and B, which is this little U shape that stands for the union of sets A and B, is going to be everything that both A and B have in it all together. 5, 10, 15, 20, and 30. Okay, and we did say that even though 10 is showing up in both of those sets, we do not duplicate that when we're looking for the union of sets A and B. Right? Then we talked about the intersection of set A and B, and following along, set A still has 10, 20, and 30 in it. Set B has 5, 10, and 15, but this time when I'm looking for the intersection of those two sets, now I am only focusing on what there is in common, which was the 10, so that's why the intersection of sets A and B are the 10. Okay, now for the complement of set A, which is typically written with this A with the line over it, but you guys are seeing, I know some of you had sent some questions that sometimes they'll write it as A with this apostrophe next to it. That can also be seen as the complement of A. I've also seen it where they write A with this little tiny C below it. So this is more often the way you're going to see it, but these two ways are also representing the complement of A, or sometimes they just write out the words complement of A or complement of B. Often on the regions, they'll just use the words complement to make things a little bit more clearer for you. But when you are finding a complement, you're going to have some larger set, in this case set S, because it has the numbers 1, 2, 3, 4, and 5, and then some smaller set that's actually a subset of that. So set A is a subset because both 3 and 5 are showing up in the larger of the two sets. So we would say that A is a subset of S. When it is a subset, then when I come along and I ask you for the complement of A, that means you are removing everything from set S that set A had in it. So in other words, I'm going to remove the 3 and the 5 since that's what set A had. Therefore, the complement of A is 1, 2, and 4. All right. You will then sometimes see writing like A unioned with its complement will equal that entire set S. That's what this is saying. Set A unioned with the complement of A is going to have the numbers 1, 2, 3, 4, and 5, which is actually set S. Other times you will see things like A intersection with its complement. That's saying, hey, what are they going to have in common? And you will sometimes see what's called the empty set. This little 0 with a line through it stands for the empty set, or you'll see an empty set of brackets. Both the 0 with a line through it and this empty set of brackets is called the empty set. I'm going to try to write it real fast, hopefully not too sloppy. Okay. All right, and you're actually going to see that right here. So let me get my highlighter because it's a little easier to highlight for you. But see the empty set, or also called the null set. There's that little 0 with a line through it, or the brackets that are empty. Both of these are your empty set. And just to give you a little bit more information, there's when we're learning about our sets, we'll learn about finite sets and infinite sets. A finite set is where it's countable. What that means, just to kind of put it in easy terms, is if I just give you a set and I say, oh, 1, 2, 3, this is a finite set. I know exactly how many elements are inside of this set. An infinite set is something that never ends. Like, for example, I can tell you the set of integers. So if I give you the set of integers, it's an infinite set because integers go on and on forever. They're countless. I have infinitely many integers. So this is an example of an infinite set, and something like 1, 2, 3 is an example of a finite set. It has a beginning and an end. Okay. All right, and we did talk about these in class. This stands for is an element of. I could say that 3 is an element of set A. I can say that 3 is not an element of set A. a little E with a line through it. We talked about subset. We can say that set A is a subset of set B. We would say that as long as everything in set A is showing up inside of set B. Union, intersection, complement. This was the heart of today's lesson. And then you have your empty set, or also known as your null set. Okay. All right, so these are some of the questions that we were doing in class. In order to do these, you do want to just note that above, I have to give you set A and set B and set C in order for us to do this. And then you just want to be careful and make sure that you're interpreting the symbol correctly. So this is your intersection. So I am looking for the intersection of set A and set B. So the intersection means what do they both have? Since they both have a 3, the intersection is 3. This is my attempt at a squiggly bracket. This is the union of set A and B. So now I'm going to list everything that they have together. So I have 1, 2, 3, 4, 5, and 6. There should be no duplication for any element that is in both. You do not write it twice. You just give me one long list of what they have all together. Again, this is the intersection of A and C. So the intersection is a 1 and a 3. For the yellow and the blue, they both have a 1 and a 3. This is the intersection. What do they both have in common? So they both have, this is the union. So that's what they have all together. So 1, 2, 3, 4, and 6. Again, this is your intersection. What do they have in common? They both have the 1 and the 3. Okay, and then this is the union where I pull everything A has with everything C has. I pull it all together. All right, this is the intersection of B and C. So what do they have in common? They both have a 3 and they both have a 4 and they both have a 6. So they both have 3, 4, and 6. Union, B and C. So I see 1, 3, 4, 5, and 6. Okay, and then I just want you to notice that I am putting them in number order. They don't have to be in number order. It's just very kind if you do that. It's easier for me to grade and so on. All right, something we may or may not have gotten into with class is, again, here's your empty set, and this is saying be unioned with the empty set. So there's one easy way to answer it. If I say to you, grab everything that set B and the empty set have all together, you could just say it's equivalent to set B. All right. Another answer would be for you to list out what set B has. Because I'm basically saying, hey, if I had the empty set and set B, then what is everything that I have? Well, I only have what set B has, since the other set is the empty set. This is an intersection. The intersection of set B and the empty set is going to equal the empty set, because if the empty set has nothing, then set B and the empty set can't possibly have the same element at any point in time. So you would just say it's the empty set. And remember, this symbol is the empty set, and so is an empty set of brackets. Those are interchangeable. Okay. This second section of questions is now going to start to throw in the complement. So again, in order for us to answer a complement question, I have to have some larger set and then a smaller set that is considered a subset of that larger set. Since 1 and 5 are both in this larger set, then I can say that A is a subset of this U, which is the universal set. Sometimes they'll reference the larger of the sets as the universal set. It's often considered the set of all possibilities. Right now it only has 1, 2, 3, 4, and 5, but since it does contain everything that set A has, it's considered a universal set for set A. Also for set B. Set B is also a subset of the universal set here, because 2 and 5 are both in that universal set, and the same with set C. Set C is a subset as well. All right, so if I wanted to come along and I said, find the complement of A, I would have to give you that universal set and set A. Since A has 1 and 5, the complement of A would be 2, 3, and 4. The complement of set B, I'm only looking at set B and the universal set. B has 2 and 5, so therefore 1, 3, and 4 is the complement of B. And the complement of C, since C only has the 2, the 1, 3, 4, and 5 are considered the complement of C. Okay, if I then say A union with B, so okay, now completely different question. I'm just looking at sets A and B, and I'm doing the union of them. So I'm going to bring together 1, 2, and 5. Those are all the elements that A and B have together. A intersectioned with B is what do A and B have in common, and the only element they have in common is A5. Now, when you get to these, my eyes are you can only look at 2 sets at a time. So I'm looking at set A, which is here, and I'm going to look at the complement of B, which is here. And I'm looking for the union of this set and this set. So that means I'm going to pull together the 1, the 3, the 4, and the 5. So sometimes you have to create one of the sets that they're using in a union or intersection situation. All right, this one, intersection of the complement of A, that's this one, and the complement of B. So that's this set. So I'm looking for the intersection of these 2 sets, and the only 2 elements I see that they have in common is 3 and 4. I'm going to use those same 2 sets to do this one, but now I'm looking for the union of the 2 of them. So if I pull these 2 together, I've got 1, 2, 3, and 4, and that's going to be my union. All right. So I'm hoping you guys are kind of okay. Feel free to rewind, fast forward, anything to kind of just get a repeat of it. All right, so now what I need you to do is see the difference between these, where I am looking at 2 different sets, and the 2 different sets that I'm looking at were the complement of A and the complement of B. And then I had this union or this intersection in between. All right, now when I have number 17, here's the difference. I am looking for the complement of the set A union B. So that means I am actually looking at this set over here, this 1, 2, 3, 4, 5. That's the set A union B. And I'm looking for the complement of that set, which is going to bring me back up to this universal set. And I am saying what is in the universal set that was not in the set A unioned with B. So A unioned with B had 1, 2, and 5. So the only elements that are still left in the universal set is 3 and 4. And that's because it had one big complement bar along that one set, A union B. So in other words, I can only find the complement of one set at a time, and I use the universal set to help me do that. So for this one, I'm looking at the set A intersection B. Here it is. The set A intersection B only has a 5 in it. So I'm looking at that universal set and I'm saying, what does the universal set have that A intersection B does not? And what it has is 1, 2, 3, and 4. So 1, 2, 3, and 4. Okay, these are typically ones kids will ask questions about in class, so we will probably talk about these more in the future, but I hope this clears up, and I know we didn't get to it today in class. I hope this helps. Okay, let's see, let's read this one. We have this universal set, 2, 4, 6, 8, and we have the complement of A. So this time they're giving us the complement of A, and they're saying, hey, what must set A itself have had in it? So that means, well, if the complement had 6, that means A must have had the 2, 4, and the 8. Okay? And that's because, remember, the set A, along with or unioned with its complement, should equal the entire universal set itself, set U. Okay? All right. I hope that's good. I mean, write down any questions that you may have, and we can definitely go over them. All right. And then one more quick concept that I want to show you is if we were to start to look at these things in a Venn diagram. All right. So I'm going to use my highlighter. It's the easiest way to do it. If I were just to say what's the elements of set A is this circle right here. So therefore, the elements in set A are going to be, right, I'm going to put them in number order, again, just for simplicity in us agreeing with all those elements. So it's going to be 1, 2, 3, 4, and 7. Those are the elements of set A. If I say what are the elements of set B, come along, I'm going to take my highlighter, and set B is all of this. So anything that is inside circle B. So therefore, I am going to say set B contains 2, 3, 5, 6, and 8. And then hopefully set C, without me even using my highlighter, set C is anything inside of this circle. So therefore, it's going to be 2, 4, 5, 6, 7, and 9. And then just be careful if I'm looking for that entire universal set. The universal set is this whole thing, all possible outcomes. So the only other number that's sneaking in is this 10 over here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How quickly can I write that? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So when I come over here and I say, hey, what is the union of A and B? So if I come up here, let me kind of start from scratch to kind of let you guys see A unioned with B. Okay. A unioned with B is going to be where A and B overlap, right? So this little section in here where I can see A is this circle and I can see B is this circle. So the 3 and the 2 is what I'm sorry, that's A intersection B. I got to be careful. So that's A intersection B, what they have in common, the 3 and the 2. Okay, A union B is all of this all together. So it's going to be everything except 9 and 10. So I'm going to write that. So the union is 1, 2, 3, 4, 5, 6, 7, and 8. Because it's everything except 9 and 10, A and B together. A unioned with C, all right? So A union with C is A and C together. So A and C together is all of this. So really, it's everything except the 8 and the 10. So 1, 2, 3, 4, 5, 6, 7, and 9 is A union C. Those two together. A intersection C. So hopefully if you look at A and you look at C, the intersection is this little spot in here. So the 4, the 7, and the 2. B intersection C. So B intersection, oh, sorry, I got to be careful. See, and be careful. It's kind of good that I make those errors because then you got to be really careful. That's a union symbol. So A unioned with C means I take everything that A and C have, which is everything except the 1 and the 10. It makes it easier for me to write. So it has 2, 3, 4, 5, 6, 7, 8, and 9. And now B intersection C is this overlapping where C, I can clean this off again. Let's see if I do it quick, I can erase it. Okay, so if I look at it, let me do my highlighter. So if I look at B is over here, and then I do, let's see if this will work. There you go. So if I do C, then the overlapping is this 5, 2, 5, and 6. Okay, that's my 5. Sorry, you guys. All right, here comes that bigger piece. So A unioned with B, right? I'm going to clear this off again. So A unioned with B is going to be, this is A, this is B, right? So this is A union with B. So now if I'm looking for the complement of that, that means anything that is in the whole big universal set that is not in A or B. So if I color, it's all this yellow, right? It's everything outside of A union B. So that means it's 9 and 10. And so really all I'm doing is I'm doing the exact type of questions that we just did before when you were looking at your set. So if I wanted to do this, I would look at A union B, which is over here, right? A union B was 1, 2, 3, 4, 5, 6, 7, 8. And the only elements that were in this universal set that were not in A union B were this 9 and 10. And that's the 9 and 10 we got. And then all I'm doing is getting you to visually see it in a Venn diagram situation. So very similar, A unioned with C. So again, we can kind of cheat and come over here. A unioned with C was 1, 2, 3, 4, 5, 6, 7, and 9. So the complement of that, what's missing is the 8 and the 10. And again, if I come up to the drawing and I look at A union C, here's A and C. What's not in A and C? There's the 8 and the 10 that we just wrote out. One more, B union with C. Again, where did I write my B union C? Here it is. So B union with C had everything except the 1 and the 10. So the complement of that is going to be that 1 and 10. If I come up and I try to look at the picture, let me erase again, the beauty of my artboard. I could keep redoing this. So that was, I already forgot, A unioned with C. So I'm going to come in and I'm going to do A unioned with C is all of this. So what elements are not in there? And there's your 8 and your 10, which we are, sorry. I hope you guys saw that. It's B unioned with C. So I will undo this. And now I'll do B unioned with C. And there's your 1 and your 10. And that's what we wrote, our 1 and our 10. And then it says, what are the elements of the complement of A? So again, if I want to look at my sets, A has 1, 2, 3, 4, and 7. The universal set was all integers, 1 through 10. So what am I missing? I have 1, 2, 3, 4. So here's 5, 6, 7 we have right here. So 7, so 8, 9, and 10. So 5, 6, 8, 9, and 10. And if you go back up to the picture, since set A contains everything in set A, that's silly to say. I'm going to highlight it. This is everything set A has. So what's not in set A is 5, 6, 8, 9, 10, which is what we had. 5, 6, 8, 9, 10. Right? So that's really what today's lesson was all about. I don't think we got into everything today, and I apologize for that. I hope this video was helpful, and if you want to try that quizzes, you're welcome to do so. All right? Have a good day, you guys.